Okay. Walaikum assalam. Okay, we shall start. Bismillah ar-Rahman ar-Rahim. So, as I mentioned yesterday, today we'll be looking at clinical scenarios, clinical disorders relating to the discussion that we've been having regarding stretch reflex. And just like we were talking yesterday, the main feature of yesterday's muscle contraction, the different things that we were discussing about muscle contractions, whether specifically when we are talking about voluntary contractions, gamma efferents play a significant role in stabilizing the whole thing, in damping of the movements, keeping the muscle spindle in the business while contracting, and so on and so forth. So that with that, all of that in mind, now we'll be looking at this thing here called the upper motor neuron lesion. Ever heard of this? Has anyone heard of this term before? Upper motor neuron. Okay. All right. Let's remedy that. We'll be looking at it a lot in the next chapter, but let me give you a brief overview of what this means. Okay. So let me draw you a very basic diagram. So let's say these are the higher centers. Okay. Welcome back. So I was saying that this here are the higher centers. This is the brain stem. Okay. And this would be your poor little alpha motor or ventral horn of the spinal cord. Okay. Let me just label it for the people who join us later. This is higher centers. Higher centers. This is brain stem. Okay, I hope you guys can see this. This is the ventral horn of the spinal cord. All right, is this clear? Is this clear? It's a very basic sort of scheme of the CNS. Come on, guys. Need some feedback. It's not clear. No, can you see it? I'm talking about the visibility. Can you see this? Yes? Okay. So, of course, you haven't done neuroanatomy, and we haven't been talking much about the higher centers. But I'm sure in sensory system, you must have heard the name higher centers or cerebral cortex, where all the sensory information is for that purpose. Higher centers basically mean cerebral cortex associated higher friends, okay? Friends of cerebral cortex in the highest level of the CNS. They reside here. All right? Then there is the workhorse, the main workhorse of the brain stem. This is where a lot of functionality technology resides. So these guys are the bosses. They conceive all the plans and the thoughts and this, that, the other, the let's do this, let's do that. Welcome back. I was talking about brain stem. So this carries out mundane maintenance related functions like keeping the heart going, the vasculature in its tone, respiration going on. Remember all those centers, respiratory centers, um, the what you call vasomotor center. They all used to reside in brainstem when we studied these in first year. Yes. Is this clear or a bit clearer than before? Right. And then here I've just made a scheme of things. The ventral horn of the spinal cord. Of course, the spinal cord would in in cross section look like something like this. It's a bit of a trick to maneuver this thing. Ah, okay. Ah, I can try it on the gray as well. Cool. And this is the ventral horn. Okay. From the dorsal horn, you get the sensory fibers into the spinal cord, and from the ventral, yes, it looks like a butterfly, Abdullah. And from the ventral horn, the motor fibers exit. Okay. Now we have some sort of an orientation. Okay. So this here is the ventral horn. This bit here. All right. We'll need some amen to this setup. Then I may proceed. All right. Osama, what about the rest? Okay, Aisha, Hafsa, and welcome back. Roheen, Raza. Okay, fine. Cool. Now, please remember the following. Okay, this will come in very handy for you, not just for neurophysiology, but also neuroanatomy. Okay, let me change the color of this and then we'll talk. So, the arrow. So, from this point, i.e., the highest centers, to this point of the CNS. So, everything and everything in between. Yeah? From this point, the highest centers, till the alpha motor neuron residing in the ventral horn of the spinal cord, and all in between, all the circuitry in between, all the descending tracts in between. Yes? If there is a problem anywhere in between, we refer to it as upper motor neuron. So this entire circuit here is referred to as upper motor neuron. Yes? And any problem with this circuit here, anywhere, it's a long one, you can understand, a very intricate one as well. Any problem from this point till this point is referred to as upper motor neuron lesion. I'll take a pause here for any questions that you may have. If no questions, then I need to have some feedback to proceed. Oh, sorry. Okay, take once more. What? Empty 99. Summary. Let me summarize it once again. Okay. So when they were discovering, and we still are, by the way, how the brain works, especially by lesions. Most of the neurophysiology, most of the neurology, in fact, has been formalized by looking at lesions, believe it or not. Because even when they dissected the brain and they looked at it, obviously functions don't pop up when you are looking at a structure, isn't it? I mean, we still don't know much about how the frontal cortex, for example, works. Okay? So, how did we come about to find out what we know today about the brain? Lesions. Lesions. So, when a part of the brain by accident, I'm talking about humans, in animal models, they of course they make the lesion to find out what is the deficit, right? But in human model, uh, whenever there is a head injury patient or a cancerous patient in which the cancer is inside the brain, and so on or trauma, where part of the brain is either it's gone or it's being compressed or the blood supply is gone, uh, they then figure out, okay, so this part, if it's damaged, what is the deficit? Which thing this guy can't do? The deficit, right? And from that they infer that, all right, this is the function of this part of the brain. Do you understand? Waiting, guys, waiting for your feedback. Either the net is slow or sometimes the chat function, sometimes it just malfunctions. Could anybody let me know on WhatsApp if you can hear me and the CR probably? Let me turn on WhatsApp. Okay, so all right, thank you. Thank you, Abdullah. Fine. I think the chat function will resume soon, inshallah, hopefully. Okay, so I will proceed. All right, Abdullah, thank you very much. That's a very interesting hairstyle. We can discuss this later, maybe. Okay, so upper motor neuron we have done. Okay, this is the upper motor neuron. So any stuff which goes wrong within this area, uh, this uh, this uh, this circuit is called upper motor neuron lesion, and the lesions they are very specific. Yani they are different from the, if it's upper there must be a lower, right? So what is the lower motor neuron? Lower motor neuron very simply is the alpha motor neuron and the muscle, till the muscle, whatever is there. Okay, so basically the nerve, the somatic nerve that comes out of the ventral horn and goes to the effector organ, whether it's a gland or a muscle. Okay, so let me just draw it here with yellow. This here is the lower motor neuron. Okay, lower motor neuron. ठीक. So features, lesions that are caused by the lower motor neuron, they are distinct, they are different lesions of the upper motor neuron. Okay, so cutting nerve coming out of the spinal cord will give you a certain clinical picture which will be different if any of the descending fibers in this area are compromised. Okay, I think I've conveyed what I wanted to convey. All right, now all of this stuff now, should I get rid of this or do you want this here a bit longer? I think WhatsApp is the way to go. Okay, guys, I think I can see the messages now. Go on, send me a message or two. Do you want this whole thing here for a bit more? Because I need to explain this now. Still no messages. Anyway, so I'm gonna clear this out to make space for the main explanation. All right. So this is a word that you will come across very frequently in neurophysiology, neuroanatomy, and then later on, inshallah, in medicine and in neurology. The word is spasticity. Okay, spasticity is a very key feature of upper motor neuron lesion. It comes from the word spasm. Okay, and just to be clear, what we are discussing this. Okay, that is more prominent. Okay, so in upper motor neuron lesions, you get spasticity, you get hyperreflexia. So the reflexes become hyper, literally. Okay, and if I just complete the picture, you get clasp knife reflex or clasp knife rigidity, and lastly clonus. Okay, these are the 5 things that I intend to cover with you, not in a very detailed manner, but enough so that you're equipped to know something about it. More of this will be covered, inshallah, when we'll be discussing the upper motor neuron lesions in detail in the next chapter. As spasticity, very simply, by the way, all of this, as you may have noticed, is due to Mr. Gamma efferent overdrive. Okay, so upper motor neuron lesions, as we are discussing here, these 5 main are mostly due to gamma efferents going berserk. Okay, it's the gamma efferents which were being, let's say, under a certain regulatory control by higher centers, but now that, welcome back. So gamma efferents, they sort of go berserk, and they go into overdrive. Okay, so you can imagine when they go into overdrive, whatever they do also gets exaggerated. Okay, right. So if you remember what they do, you would remember that the muscle spindle, now when they are exaggerated, I need to switch this off. Now when they are exaggerated, the muscle spindle is very, very tense. And what we mean by that is that it is super sensitive to any change in length of the muscle. I think that bit should be very, very clear now. Okay, so when you have this sort of situation, when you have stretched it out unnaturally, excessively, the spindle mediated stretch reflex also goes into overdrive. Okay, this is just out of yesterday's lectures. Okay, so I hope this is clear. So when you have a perpetual issue with gamma motor efferents, um, disturbing the equilibrium of the spindle by overstretching it unnecessarily, you have a situation of the stretch reflex following suit and getting disturbed and activated abnormally, which then leads to a which the muscle spindle stretch reflex will trigger, and this will not go away, because remember, when it will try to contract and relieve the stretch, it can't relieve the stretch, because it is being unnaturally, abnormally getting stretched by the gamma efferents, because they have gone berserk, and that is not stopping. So no matter what you do with contraction, you will not be able to, quote unquote, relieve the. Okay, I can see some things. Berserk is a beautiful word. That was probably the last comment Abdullah made. Could you guys tell me if this up till now is clear? Do you understand why the muscle goes into spasm? Because of gamma motor efferent motor overdrive. How about you press the like button, so I know that you because I can see the like button. Hurry up, hurry up. Okay. So, all right. Okay, I have some sort of feedback. Okay, thank you. So it's there. Number two is hypertonia. So if you understand how spasticity happens, this is just hypertonia. The tone of the muscle will also increase to abnormal levels. Hyper. Okay, and if you remember, the stretch reflex has two components. The stretch reflex that we have just been discussing. Yesterday we discussed that it has a tonic component and it has a phasic component. Okay, so because of the tonic component going haywire, you will have hypertonia, and due to the phasic portion going abnormally increased, you will have hyperreflexia. Okay, so what is hypertonia? Abnormal tone. All the muscles in a person who is alive, partial contraction. So in between Genon puts it very nicely, in between hypo and hyper, just in the middle somewhere, hypothetical, not hypothetical, arbitrarily, in the center of hypo and hypertonia, there is the normal tone or tone. We just call it tone or tonus of the muscle. So all of our muscles are in a condition, in a situation of tone, which is normal. However, any decrease in that tone due to gamma efferent or muscle spindle issues, we call it hyper. Welcome back. Same is the case with hyperreflexia. So you have reflexes which, after clinical experience, and in your case at the moment, after watching lots of YouTube videos on reflexes, you will get a sense of what normal reflexes are. How? When you elicit, say, and this is part of your practical schedule, by the way, you'll be eliciting, say, the knee jerk, okay, the ankle jerk, the elbow, and so on and so forth. When you do, specifically when you do the knee jerk, the knee extends. Now in a normal person, the angle that it goes to, you will get a sense when you have experience with this, okay, and the velocity with which it's carried out. However, in hyperreflexia, the speed increases, and so is the range of motion. It also increases. Okay, right. I'll just say okay, and I'll just say right myself because maybe inshallah when we disconnect and reconnect for the second lecture, this will sort itself out. It did happen in the MLT and the BSN lectures as well. I hope that this is sorted out by next time. Okay, so these are the three things. I hope you got all of that. Okay, and remember these slides are available. The lecture, sorry, is available. So are the slides, by the way, if anybody wants it. So we move on to 2. So this is the second last point, the clasp knife reflex. I hope you can see the clasp knife. You know those, remember those Swiss knives, the multifunctional knives which have the nail cutter and God knows what else in there. Okay. Now, the point here is how they open. If you had the experience in a peculiar fashion, okay, let me just zoom out and show you. So if, let's say, if this is the clasp knife, okay, it will have all the blades in there and you pluck one of them out. When you're doing that, plucking out, it really resists. If you have opened one, you know exactly what I'm talking about. But once you try to pluck one out, it really resists. But then it just opens. Once the initial resistance is done, you overcome that, it just really swings open. Okay? So, welcome back. As I was saying, clasp knife reflex is due to a problem with the, again, muscle spindle, and the culprit again is gamma efferent. Okay? So what happens? Let me just show you the video and then explain it. All right? I hope you guys can see this. Now, this gentleman here, he's playing the doctor, and this guy, he's a normal guy. He's just somebody who is has been asked to demonstrate what the clasp knife reflex is. Okay, he goes on to show you what the cogwheel rigidity is there as well. But I'm just focusing on the clasp knife bit. Okay, so I'm going to play this video now for you guys to see what the clasp knife reflex is. Okay. So he basically is asked, he will passively flex his elbow. Okay, he's about to passively, there's resistance, and then right at the end the resistance goes. So again he demonstrates flex, resistance, and then it just goes. Okay, this is clasp knife rigidity or response or reflex. Okay, another video in which you can see the lower limbs. So this is an actual patient. Okay, see the resistance initially and then just the give in at the end. There you go. Okay, I hope that you got that. All you need to do is just type in clasp knife reflex or clasp knife rigidity in YouTube and you're good to go. Now, let me just explain to you what just happened. Okay, say in the first video where he was trying to flex the bicep. Okay, what was happening in the tricep? The tricep was being stretched, right? So if there is a problem in the tricep muscle, welcome back. The muscle that has been stretched due to overactivity of gamma efferents will be spastic, obviously, naturally. So when you are trying to flex the elbow, you are basically increasing the extension of the triceps. I really hope I get some sort of feedback on this. You understand this. This is first year upper limb anatomy. Okay? So the bicep is the flexor and tricep is the extensor, right? So if you are flexing it, the tricep is being pressured into extension. So it's initially it resists by contracting it, the muscle. Okay, it's typical stretch reflex wali contraction. Okay, so in the initial part, what you see the patient's muscle getting resistance is the opposing muscle trying to resist the extension by contracting it by it's a typical stretch reflex, and it's exaggerated. The whole thing is exaggerated because of the gamma efferents. This is it. Moderate stretch leads to muscle contraction. Okay, this bit is okay. This is a sequence of moderate stretch. You saw the moderate stretch, and it led to contraction, which can be viewed as the initial resistance put up by the person. Okay, but then what happens later on? Later on, later on, later on, when you increase, you persist with your bending movement, in this case the flexion of the elbow. When you persist, the muscle just gives in, it relaxes. Okay, this here, the relaxation, this is due to Golgi tendon organ reflex, which we discuss straight away after this presentation. Okay, so just hang in there. Okay, this here, the muscle stretch inducing muscle contraction, this is due to your muscle spindle stretch reflex, while the eventual relaxation and giving in is due to GTO, inverse myotactic reflex or inverse stretch reflex. Okay, you will understand this complete sequence when we'll discuss, inshallah, in a bit, the GTO reflex. Okay, now I'm turning on Abdullah could just thing can't connect. It's connected to the phone, isn't it? Anyway, chalo. Let me just complete this as well, and I'll disconnect and reconnect the live chat, this whole thing, and we can have questions. Okay? Right. Okay. My computer is also protesting. I'm sure you are protesting as well. Okay. So the last thing, and don't worry, I'll just show you the video. You like the gamma efferents in stretch to a muscle, which regular, repetitive, rhythmic contractions, and if they are sustained for 5 or more beats. Welcome back. So normal people can induce a clonus in their muscles. It should be less than 5 beats. Okay. If it's sustained beyond 5 beats, then it's considered abnormal. What am I talking about? Let's see here. Now I'll show you clonus. Okay. So this gentleman is the doctor. Okay. And this gentleman is the patient. Here goes. He's doing the knee jerk first, then the ankle jerk, and now he'll go for the clonus. Look. So look at the placement. He has ankle here, okay, and now he'll push it up. So he'll apply what I mentioned was sustained stretch. He will push it up so that the whole joint here goes into stretch, like this. Yeah. So he has pushed it up and he has kept it like that. This is the sustained stretch that I was talking about, and look what happened. This is clonus. Another very clear video is this. Here he has stabilized, the patient is obviously lying down. He has stabilized the ankle by putting one hand underneath that, the lower limb, the lower part of the leg. Okay, and check this out. this guy just, this is clonus. It's going with, even without the sustained stretch. So the damage to the upper motor neurons is quite bad. Okay? So this was the maintained or sustained stretch which led to regular, repetitive, rhythmic contractions. Okay? So this was the part of the presentation which concludes our clinical reflex gamma efferents. So the first block of the first chapter we've done, okay? And I'm gonna disconnect and reconnect before we start the inverse stretch reflex, the GTO mediated stretch reflex, okay? So I'm just disconnecting now and reconnecting so that we can talk. I'll give you some time to, if you have any questions about these 5 issues, we can thrash them out and then proceed with the lecture. All right, thank you.